Hey guys, how we doing? It is section 5 of chapter 8. Still talking about really the same shapes in a way.
Yeah.
Quadrilateral still, but just different types of those, a little bit more unique. So here's the first kind. So far we've talked about general quadrilaterals that just have 4 sides to them. Then we specified that to quadrilaterals that were parallelograms. And remember, that meant that both pairs of opposite sides were parallel. We had some other properties of them and so on. But this is a unique shape here called a trapezoid that is a quadrilateral, still a 4-sided shape, but it only has one pair of parallel sides. So specifically, the other pair cannot be parallel, or else it would be a parallelogram. So a trapezoid is different from a parallelogram. It only has one pair. And so you could have something like this. You could have to where this leg on the left-hand side is straight up at a 90. And the other one is not at a 90. You can have all kinds of different trapezoids here, but those are the most common ones that we see. And so the 2 sides that are parallel to each other, we refer to those as bases. The 2 parallel sides are the bases of the trapezoid, and the 2 non-parallel sides we call legs. And really, if you think about it, a trapezoid is just a triangle cut off.
Yep. Got a flat top.
Yep. Yeah. So. Okay, and then we have a second kind of shape that is, again, quadrilateral but not a parallelogram, called kites. And they're called kites because they're shaped like a kite. And so they're quadrilaterals, 4-sided shapes that have 2 pairs of congruent sides, but they're next to each other instead of opposite from each other. And so a kite has, as you can see on the left side of this, the 2 short sides are congruent to each other, and on the right side, the 2 long sides are congruent to each other, and that's what creates a kite. And kites have some special properties to them. Each of these shapes have some special properties to them. And so that's what we're going to look at here. Anything else there?
No, I mean, when I think of a kite, I just think of 2 isosceles triangles being smushed together.
Stacked on top of each other?
Exactly. That way you can kind of visualize
Bases
those 2
on each
pairs
other.
of opposite sides, yeah.
And in fact, a lot of the diagrams we have will do that.
Yeah.
We'll be talking about the triangles that are built inside.
Right, right.
So if you can think about the sticks of a kite
Yeah.
that make up a kite, that's what will kind of split up the triangles that we're talking about.
Right.
So.
Right. All right, so isosceles trapezoids. Speaking of isosceles.
Special one, yeah.
Yeah, so isosceles trapezoids, guys, just take the definition of a regular trapezoid and just refine it a little bit more. So remember, the definition of a normal trapezoid is it's a quadrilateral with 1 set of parallel sides. Well, an isosceles trapezoid takes it 1 step further. It still has 1 set of parallel sides, but then those 2 legs that Mr. Scritchfield was talking about earlier are congruent. And if you think about it, it would be like an isosceles triangle where they just cut off the top piece and parallel to the bottom piece, and then you have those congruent sides. And so you got to remember that on an isosceles triangle, those base angles were congruent, and that rule also applies here, that the base angles of an isosceles trapezoid are also congruent. Now, you can turn that trapezoid over, guys, and have another set of base angles, just depending on which way you're looking, and it'll kind of come up here on that. So there's that first set of base angles, and those are congruent there. And then if you flipped it over and stood it on that small edge, which you could still do because it's a base, you would have another set of congruent angles or congruent base angles. Now, here's another thing. What do you think? Okay, just looking at this, make an educated guess on what you think that those consecutive, the acute and the obtuse angle above it, what do you think those are going to add up to, guys? If you look at it, they're going to add up to 180. You've got a set of parallel lines, so you have consecutive interior angles right there on the left and on the right, and those consecutive interior angles are congruent, okay, are supplementary. Yeah. And so that's another important thing to know about this, and they're going to kind of test you on some of that. You got to be able to put these things together. Hopefully you visualize that and put that together. And here it is right here. So if the upper left corner is 118, well, we know that it's an obtuse angle, and so the other obtuse angle is going to be congruent to that because that's the other base angle. So X must also be 118. Kind of. That's supposed to be 118. And then Y, guys, would just be, 180 minus 118. And so you get, 62? And there it is right there. And so if Y is 62, then that other acute angle on the other side is also going to be 62.
Right.
So, just some other little things here that you should be able to pull out of this.
No, you can only do that. So basically what we did is we found the other 3 angles given only 1 angle, but you can only do that in an isosceles trapezoid.
Yes.
Just because of the rules that we just talked about. So.
Yeah, so remember that. That's important. All right, so If it's isosceles, each pair of base angles are congruent, which we covered, and it's an isosceles triangle if and only if its diagonals are congruent. So here's another rule
Now
for this.
that kind of throws a strange thing in here, because the only other shape that has that is a rectangle.
It's a rectangle, that's right.
And so it's kind of weird that an isosceles trapezoid has congruent diagonals, but that's one of the properties of it.
I guess for me, how I always kind of made sense of this is if I cut that left triangle off the edge of that trapezoid, flipped it over, and attached it to the other side, I would get a perfect rectangle.
That's true.
Yeah, so that's kind of how I always got figured out, or in my own head, how that would work out, where we'd have those congruent diagonals, because it's basically a rectangle where they've just kind of cut that triangle off.
Right.
You know, so
those rules are talking about trapezoids, but only isosceles trapezoids.
only isosceles
Are those two
trapezoids.
things true?
So you got 3 rules for isosceles trapezoids. You know, you got the diagonals are congruent, you got those base angles are congruent, and then you got those
The
legs are also congruent. Okay.
Yep.
So if we have this problem right here, we have EF is parallel. We have a trapezoid here. Let's see what they're going to ask us to do here. So we're going to say if EG is congruent to FH, okay, so if diagonal EG is congruent to diagonal FH, then EFGH is an isosceles trapezoid. And so they're asking, is that true or false? And the answer is true there. And so, whoops. So we would say yes, or this is just showing you that that would make it an isosceles trapezoid. So if they didn't give you any other information except parallel sides and 2 congruent diagonals, you could assume that it's an isosceles trapezoid, is basically what they're trying to get you to see.
Yeah, that one's kind of flipped over from the top one, just so you can see one turn the other way.
Yep.
So, all right. Mid-segments. Remember, we had mid-segments of triangles, and a mid-segment of a triangle was if you connect 2 midpoints of any 2 sides, that segment was a mid-segment. Same thing here. Okay, but we're always connecting the midpoints of the legs of a trapezoid. Okay, we don't connect the midpoints of the 2 parallel sides, only the legs. So if we connect the midpoints of the 2 legs, okay, that segment in this particular diagram, the green segment there, because M is a midpoint and N is a midpoint, so that green segment has to be parallel to the other 2 bases. So it's parallel to the top, parallel to the bottom, that are already parallel to each other. Okay, and here's the rule of how to find it. I don't know if you remember from before with triangles, but it was always half of the 3rd side. Well, now it's half of the 2 sides added up. And so it's the average of the bases. Okay, so remember how to find average of 2 numbers, add the 2 together, divide by 2, because there are 2 of them. Okay, so if we had an example here where the top base is 27 and the bottom base is 53, we want to find the average of those 2. We would just add those together, and so that's going to add up to 80 and divide by 2. And so that segment in the middle, the mid segment, is going to be 40 units long here. Okay, so the middle one is just the average of the other 2. Okay, always talking about the parallel sides there, the 2 bases. Well, this is a little bit harder here. If they give you the mid segment and you have to find one of the other pieces, a little more difficult to do. But if you think about the operation that we did in the other one and just reverse it, then looking back at the other one, if you were given that 40 in the middle, you would just double that, 80, and 80 is what the other 2 bases have to add up to. So you could do the same thing here. We have that 12.5 in the middle, and so if you double that, that would be 25. And so the 2 bases, top and bottom, have to add up to 25. So if we subtract the 1 base that we do know, 15, that would give us 10, and the 3x plus 1 then would have to equal 10. And so you could solve it from there. That's one way of doing it anyway. Okay. The other way of doing it is by adding the 2 bases together. You know, this is just the average. Adding the 2 bases together, 3x plus 1 is the top base, the bottom base is 15, dividing that by 2, and setting that equal to 12.5. But if you do the operations, the algebraic operations here, it's going to be what I was just saying. If we multiply both sides by 2, you're going to get 25 on the right side. Okay. And then if we combine the 1 and the 15 and then subtract that, we would get 3x is equal to 9, and so x would equal 3. So if it makes more sense to you to just double that mid-segment to make it 25, subtract the bottom one, that would give you 10. So the top one has to be 3x plus 10, subtract 1, 3x equals 9, divide by 3, x would have to equal 3 then. Okay? But those are the harder kind.
Yeah.
When they give you the middle, when they give you the mid-segment and ask you to find one of the bases. So, but notice each of these diagrams are telling you that it's the midpoints of the 2 legs because of the congruent segments that are shown there. Okay, that's another way of showing that it's a midpoint besides just telling you that it's a midpoint. Okay?
All right, so for the kites kind of share some pieces of different shapes we've already looked at. when we talk about its diagonals, okay, so it's going to vary, it's going to get a little bit different than the trapezoid here, but kites have perpendicular diagonals. So kind of like a rhombus, where the rhombus's diagonals form a perpendicular. Kites, same thing. A kite's diagonals will form a perpendicular, and then once again, one pair of opposite angles are congruent. Now this is kind of the tricky thing, but well, it's not really tricky. It's more of a visual thing. If you look at this kite here, you know, and you look at it, which two sets of opposite angles actually look like they're congruent? Well, if you look in the diagram there, C and A look very close, whereas D looks like it's a lot smaller than B, and so, you know, those opposite angles wouldn't be congruent, but C and A definitely would. So on that kite, you're going to have that one set of opposite angles that's always going to be congruent. That's how they work. So, you know, diagonals make perpendicular, and then one set of opposite angles will also be congruent. And it's usually the you know, not the extreme measures. It's usually the ones kind of in the middle. Okay, so they give us this picture here, and now we're going to have to try to figure out a couple angles and a few sides here. Okay, guys? So they say if the measurement of XYZ is 80 and the measurement of XWZ is 48, find the measurement of WXY. So we want to find that angle up there on the top, okay, when we've been given the angle on the left and the angle on the right. Now remember that WXY is exactly the same as WZY because those are the opposite angles that are congruent. Okay, I mean where W is at and where Y is at, those don't look the same. Okay, anyway, so because it's quadrilateral, guys, you got to remember it adds up to 360. So the best way to go about doing this is to go, okay, I have a 48-degree angle, I have an 80-degree angle. If I add those two together, okay, I get 128. If I subtract that from 360, that leaves me 232, okay, between those two angles. And so then I just divide 232 in half, and I get that WXY is 116.
Yep.
And so I know I'm going a little bit fast here, but I mean, that's just kind of the way you got to do it. Okay. Now, for XY and WX, okay, what you're going to have to do here is use a little bit of Pythagorean theorem to find those pieces, because XY is the hypotenuse of that triangle in the upper right-hand corner, and WX is the hypotenuse of the triangle in the upper left-hand corner. So they give me OY as 6, and they give me WO as 8. So I can use Pythagorean theorem to figure out that third side, because remember, the diagonals of a kite meet at a 90-degree angle. So that allows me to use, you know, my right triangle rules, and Pythagorean theorem is the best way to go. So if I just set this up as the square root of 6 squared, which is 36, minus 2 squared, which is 4, I get the square root of 40, okay? And so the square root of 40 is 2 root 10, okay? 4 times 10, you can take the 4 down, square root that, you get 2 root 10, okay? Now, for the other one, I'm going to do the exact same thing, okay? So all I'm going to do now is I'm going to go 8 squared, which is 64, plus 4 squared, which is 16, which gives me a total of, what is that, 80? And so then...
it's just 2 squared.
Oh, 2 squared, so 4. Yeah, so 68.
Plus 4. So
yeah, 68. And so once I square root 68, we'll just look and cheat here. That's going to give me 4 times 17, so what is that? 68. 68. So, yep. So then I just take the 4 out again, and it's 2 root 17.
Yep.
So, I mean, you know, just try to take this in, and we'll be looking at it again tomorrow. So.
Yep. Okay, we'll see you in class, guys.